According to the 2020 National Electrical Code, Table 110.26, 8.1 states that working space in front of electrical equipment shall not be less than 3 feet, which is 914 millimeters, clear and accessible. This establishes a minimum clearance requirement to ensure the safety of personnel working on or near electrical equipment. The key phrase here is clear and accessible, which implies an unobstructed and readily available space for operation and maintenance. In the situation described, the approved doorway opening is 36 inches. However, this dimension alone does not fulfill the requirements for working space in front of the panel board. The NEC mandates a minimum depth of 36 inches, or 3 feet, of clear space extending outward from the enclosure. The doorway's width does not compensate for the insufficient depth of the room. Therefore, the doorway opening alone cannot be used as the sole determinant of clearance in front of the equipment. Moreover, Section 110.26 E of the 2020 NEC addresses the accessibility of electrical equipment. It states that access to electrical equipment shall not be obstructed by permanent fixtures or by unauthorized materials. This provision aims to maintain unimpeded access for inspection, maintenance, and repair activities. In the scenario presented, the panel board is situated in a room that is only 32 inches deep. Consequently, there may not be sufficient space to open the door fully without encountering an obstruction. This restricted access violates the requirements outlined in NEC Section 110.26. To elaborate further, the NEC emphasis on clear and accessible working space stems from the inherent hazards associated with electrical work. Firstly, adequate space allows personnel to perform tasks safely and efficiently, minimizing the risk of accidental contact with energized components. Secondly, sufficient room enables the use of necessary tools and equipment without compromising safety. Thirdly, clear access facilitates quick egress in emergency situations such as electrical fires or equipment malfunctions. The depth of the working space, as specified in Table 110.26, A1, is determined by the voltage to ground, the condition of the installation, and other factors. In many typical installations, a minimum of 3 feet is required for systems operating at 150 volts or less to ground. For systems operating at higher voltages, the required depth increases accordingly. The intent behind these varying depths is to provide a safe buffer zone that reduces the likelihood of electrical shock or arc flash hazards. In the context of panelboard installations, the working space should extend horizontally from the edge of the equipment. This horizontal clearance ensures that personnel have sufficient room to maneuver and perform tasks such as opening the enclosure, inspecting components, and taking measurements. The working space should also extend vertically from the floor or platform to a height of at least 6 feet, 6 inches, or 1.98 meters, or the height of the equipment, whichever is greater. This vertical clearance prevents obstructions from interfering with the workers' movements. It's crucial to consider the overall layout of the room or area where the panel board is installed. Obstructions such as pipes, ducts, or structural elements can impede access and reduce the effective working space. Any such obstructions must be addressed to ensure compliance with NEC requirements. The authority having jurisdiction, or OJ, plays a vital role in interpreting and enforcing the NEC. While the AHJ has the discretion to make certain interpretations or grant exceptions, these decisions must be based on sound engineering judgment and must not compromise safety. In this case, the AHJ approval of a 36-inch doorway opening and a door locked in the open position is satisfying the requirement of Table 110.26. A1 raises concerns. As previously explained, the doorway opening alone does not guarantee the required clear working space. Additionally, the 32-inch depth of the room further exacerbates the issue of accessibility. It is advisable to engage in a constructive dialogue with the AHJ to address these concerns and explore alternative solutions. Potential solutions may include relocating the panelboard to a more suitable location, increasing the depth of the room, or implementing other measures to ensure compliance with the NEC. It's important to document all communication and agreements with the AHJ to avoid future misunderstandings. In addition to the specific requirements outlined in sections 110.26 A1 and 110.26 E, the NEC contains numerous other provisions related to electrical safety. These provisions cover a wide range of topics, including grounding, overcurrent protection, wiring methods, and equipment installation. Adherence to these requirements is essential to protect personnel and property from electrical hazards. Electrical installation should be performed by qualified and licensed electricians who are knowledgeable about the NEC and other applicable codes and standards. Regular inspections and maintenance are also crucial to ensure the continued safety and reliability of electrical systems. It's worth noting that the NEC is a living document that is updated every 3 years. These updates reflect advancements in technology, changes in industry practices, and lessons learned from past incidents. Staying current with the latest edition of the NEC is essential for electrical professionals and anyone involved in the design, installation, or maintenance of electrical systems. To summarize, the NEC requires a minimum of 36 inches of clear and accessible working space in front of electrical equipment. The doorway opening alone cannot be used as the clearance in front of the equipment. Access to electrical equipment shall not be obstructed by permanent fixtures or by unauthorized materials. The panelboard is located in a room that is only 32 inches deep, which means that there is not enough space to open the door to the panelboard without hitting something. Therefore, the panelboard is not accessible and does not meet the requirements of the NEC. In addition to these code requirements, it is always important to consider safety when working with electricity. Always to energize equipment before working on it, use appropriate personal protective equipment, and follow safe work practices. Proper planning and adherence to safety protocols can significantly reduce the risk of electrical accidents. The NEC is not intended to be a design manual, but rather a set of minimum safety standards. It is the responsibility of qualified professionals to apply sound engineering judgment and design electrical systems that meet or exceed these minimum requirements. Furthermore, the NEC should be viewed as a complement to, not a substitute for, proper training and experience. Electrical work is inherently dangerous and should only be performed by individuals who are adequately trained and qualified. To further elaborate on the implications of non-compliance with NEC 110.26 A1 and 110.26 E, consider the potential consequences in the event of an electrical emergency. Firstly, if the working space is inadequate, personnel may be unable to safely access the equipment to shut it down or perform emergency repairs. This delay could exacerbate the situation and lead to more severe damage or injuries. Secondly, if access to the equipment is obstructed, firefighters or other emergency responders may be unable to reach the equipment quickly and effectively. This could hinder their ability to contain a fire or mitigate other hazards. Thirdly, non-compliance with NEC requirements can result in significant legal and financial liabilities. Insurance companies may deny coverage for claims resulting from code violations. Building owners or contractors may face fines, penalties, or even criminal charges. Therefore, it's imperative to prioritize compliance with the NEC and other applicable codes and standards to protect personnel, property, and financial interests. When evaluating the adequacy of working space, it's important to consider the types of tasks that will be performed on or near the equipment. For example, if the equipment requires frequent maintenance or calibration, a larger working space may be necessary to accommodate the tools and equipment needed for these tasks. Similarly, if the equipment is located in a high-traffic area, additional clearance may be needed to prevent accidental contact or obstruction. In addition to the physical dimensions of the working space, it's also important to consider the environmental conditions. Factors such as temperature, humidity, and lighting can affect the safety and comfort of personnel working in the area. Proper ventilation and illumination are essential to ensure a safe and productive work environment. In some cases, it may be necessary to install supplemental lighting or ventilation to meet these requirements. Furthermore, it is crucial to maintain the working space in a clean and orderly condition. Clutter, debris, or other obstructions can create tripping hazards and impede access to the equipment. Regular housekeeping is essential to ensure a safe and efficient work environment. In the specific scenario described, the 32-inch depth of the room presents a significant challenge to compliance with NEC requirements. While it may be possible to obtain a variance or waiver from the AHA, this should only be considered as a last resort. It's generally preferable to modify the installation to comply with the code requirements. One potential solution would be to relocate the panel board to a different location where adequate working space is available. Alternatively, it may be possible to expand the room to provide the required depth. However, these options may not always be feasible due to physical constraints or cost considerations. Another potential solution would be to use a panel board with a reduced depth. However, this may not be possible if the existing panel board is already the smallest available size. In some cases, it may be possible to use a combination of these approaches to achieve compliance. For example, the panel board could be relocated to a slightly larger location, and a smaller panel board could be used to minimize the depth requirements. Ultimately, the best solution will depend on the specific circumstances of the installation. It is important to carefully evaluate all available options and consult with qualified professionals to determine the most appropriate course of action. The NEC provides a framework for ensuring electrical safety, but it is not a substitute for sound engineering judgment and careful planning. By understanding the code requirements and applying them intelligently, it is possible to create safe and reliable electrical installations.